Today we discussed a problem related to graph. In the problem they give input an integer related to number of courses, and they give 2D array. It is prerequisites, and third one is it is also a 2D array. It is queries. So in the prerequisites they give two integers in each array. For example, they give an ij. What is the prerequisites meaning is before you complete this jth work, you have to complete this ith work. This is the prerequisites. This is, you want to print the output whether, for example, they give in the queries u and v. You have to tell that the u is a prerequisite of v or not based on the prerequisites. So before going to the solution, you want to know the topic. Before going to the solution of this problem, you have to know what is meant by topological sort. Topological sort. For example, you have imagined there is a graph like this: 1, 2, 3, and 4. What is meant by topological sort means you have to print in the way the dependence. First you have to complete 1. After that you have to complete 2 and 3. So for this the topological sort is. So here the topological sort is there is an edge between 1 and 2. The rule is you have to complete the work 1 before you go to the 2. So the topological sort for this is 1, 2, and there is an edge between 1 and 3. So you have to complete 1. After that you have to go to 3. You have already completed 1. So you will print 3, and before complete 4, you have to complete this 2 and 3. 2 and 3 are already completed. So you print 4. This is the topological sort. When you know about this topological sort, what is topological sort, you immediately click the given question what you want to use. So we come to the solution to the problem. Then these are the inputs. The number of courses is 3, and the prerequisites are these, and the queries will be given like this. So you want to print the topological sort based on the given prerequisites. Before that, you want to construct an array list. So we know that the number of courses are 3. So you have to construct an array list of size 3, 0, 1, 2. What they given? 0, 1. So what is their criteria? You have to complete 0th work before 1. So the dependency line is like this. So the Indegree for 0th list you have to add 1, and when come to 1 and 2, for in the 1 we have to add 2. This is the array list. So we earlier discussed the topological sort. For that we have to maintain an array that is in degree for each vertex. We have to maintain an array in degree for each vertex. Here the Indegree is 0 goes to 1. So there is only 3 courses now. We have to maintain the array list of size 3. 0, 1, 2. The Indegree of 1 is 1. The Indegree of 2 is 1. The Indegree of 0 is 0. There is no Indegree for 0. So, and for the topological sort, we want to use so you have to use a queue to print the topological sort. That is queue. Let's imagine it is queue. We have to push into the queue the vertices who have Indegree is 0, because there is no need to process the vertices, because there is no vertices before that vertex who having the Indegree 0. So here the Indegree 0 vertex is 0 only. So we have to push the 0th vertex into this and process the queue. While queue is not empty, yes, the queue is not empty, we have to process what are the elements present in the queue. For now, in the queue there is only one element, so that is 0. So we have to pop this. Pop. What you get when you pop the queue? You get 0. 0 means in the topological sort we have to add 0. So we have to subtract the Indegree of vertices which is depend on zeros. So the and add to the topological sequence, and we have to process the vertices which are depend on this 0. Means we have to process the all vertices that is under the list 0. So for in I, what is this? When we click this array list dot get of 0, what we get? There is only one element. So here what is the one element? That is 1. So we have to decrease the Indegree of 1 to, we have to decrease degree of 1 now. So in the degree it is changed. In the Indegree of 1 it goes to 0. So again you want to check that after reducing the Indegree of the you have to check the Indegree is 0, you have to push that vertex into the queue. So here the one for the Indegree of 1 is 0. So we have to push that vertex into queue, that is 1. So again it goes to while loop, you check in the while loop. You can see there is the queue is not empty. So it goes into the while loop and again repeat the same process. So again it repeat the same process, that is we have to pop up the 1 and we have to decrease the vertices which are dependent on this 1. So for that we have to get the elements present in the 1 index in the array list. So for that we have to use for loop for int I, what you want to get the vertex present in the list of index 1. So a lot get of 1. So what are the elements present? 2 only. So we have to reduce the Indegree of 2 to decrease 1 time. So it is 0. And I forget that we have to pop up. Immediately when we pop up 1, we have to add in the topological sort. After that the Indegree of 2 also becomes 0. So again we have to add into the queue the vertex 2. After that again it goes to while loop and it is pop up. Immediately popping up, we have to add to the topological sort and you have to reduce the Indegree of the vertices which are dependent on the 2. So in 2, when you see there is no elements, so here the queue becomes empty. This for loop gets ended. What you want to print, whether you want to check whether the 0 is prerequisite of 1. Immediately, maybe some students will think like that, traverse through the topological sort, get the index of these 2. For example, take this 0 and 1. Let's store it in 2 variables. I is equal to 0 and j is equal to 1. We have to traverse. It is 0. Vertices are 0, 1, 2. The 0 is at index 0. 1 is at index 1. Then the vertex of 0 is less than vertex of j, means 0 is coming before 1. So it is what you understand that 0 is prerequisite of 1. So simply by traversing the topological sort, when you get the index of the first element is less than the index of j, you conclude that that first vertex is prerequisite of second element. But I will show one encounter example. For example, the graph is like that. 0, 1. It is a graph 0, 1 and 2, 3. In this graph, when you perform the topological sort, what you get? 0, 1, 2, 3. In the query, they ask when they are asking 1 and 2. In the query, they give 1 and 2. We have to check that 1 and 2. We have to check that the 1 is prerequisite of 2 or not. What is our assumption? While traversing the topological sort, when the index of 1 is less than 2, it is definitely 1 is prerequisite of 2. So we can definitely get the index of 1 less than 2. But when you observe in the graph, there is no relationship between 1 and 2. So in this case, our assumption will be goes to wrong. So our assumption, where is our assumption missing is, I will tell with an example, 0, 1, 2. So they given in the prerequisites, they given 0 and 1. They given 1 and 2. When you observe that 0 is prerequisite of 1. 1 is prerequisite of 2. So indirectly for the 2, 0 is the prerequisite. So what you understand is, 0 is prerequisite of 1. 1 is prerequisite of 2. So when you observe that indirectly the 0 is prerequisite of 2. So here we are missing. So what we understand that for the present vertex, what are the prerequisites of 1 are also prerequisites of 2. So what you understand is, while popping from the queue, you have to make sure that maintain a relationship of what are the vertices depend on 1 are also dependent to this 2th vertex also. So now I think you understand what is the drawback of our previous approach. I will introduce one more structure, that is 2D array, that is Boolean. Boolean 2D array, that is Boolean 2D array. It tells you how to store, you have to store the relationship between 2 vertices. So how many nodes are there? There are 3 nodes. So for example, I will show you the 2D array of Boolean will look like that. Initially you have to fill all this with false. So I will explain from starting. So what is the first we have to push the elements into the queue whose vertices have Indegree 0. So here the 0th vertex have only the Indegree 0. So in the queue there is only, we have to push 0 and process the 0. And in the 0 there is only one element in the 0. So so in the Indegree there is only one element that have the Indegree 0, that is 0. We have to push the 0 into the queue and process the vertices which are dependent on the 0. Those are contains at the index 0 in the array list. So in the array list there is only one element, so we have to decrease the Indegree to -1, it gets 1. So we have to, first we have to pop the 0, top element, pop 0 and process the neighbors of 0. Here for neighbors of 0 there is only one element. We have to process that, means we have to decrease the neighbors of 0 by 1 in degree. So there is only one is the neighbor. In the Indegree you have to decrease by 1, it gets 0. Immediately when you get the Indegree as 0, you have to add queue this vertex. So now in our queue 1 will be there. 1 will be. So now we have to process the what are the neighbors present to the 1. Before I will forget one thing, we have to maintain the relationship now. So the 0 to 1 there is a relationship. So you can make this as true when, and we have to pop 1 and to process the 1 index. There is only one element 2. So we have to, for 1 and 2 we have to make it as 2 and process this element. So we get 0 and here we have to add 2. After that we have to process this. Here our discussion came into process. What you discussed that here the parent element is what for this. For 2 the prerequisite is 1. For 2 prerequisite is 1. So we have to maintain relation between two neighbors of 1. I think you understand what the statement I am telling is. Here the current element is 1, top element is 1, the neighbors are 2. So we have to check what are the prerequisites of 1. It may be any vertex, it may be. So we have to treat this other nodes. Treat this are so we have to check what are the prerequisites of 1. When you observe this column, here the true. What is this means? The 0th vertex is the prerequisites of 1. So before processing 2, we have to maintain maintain relationship 0 to 2, because the 0 is prerequisite of 1, but 1 is the prerequisite. So while processing the neighbors of the present element, we have to check what are the prerequisites of our pop element. So let's 1 is our present pop element. So the neighbors are 2. Before processing 2, we have to check what are the prerequisites of 1. So for that we have to use this 2D array. The prerequisites of 1 we have to traverse through column wise. So when you check the 0, 1, 0 is the prerequisite. So it is true. Yeah. So well, example, our present popped element. So let's consider our present popped element is E, that is 1, and processing neighbors are 2. So what we want to do is for it I is equal to 0 to I less than 3 I plus plus, because there is only 3 vertices, so I'll directly mention integer values only. If what is our present element E, if any if your vertex, I mean let's treat it as B. When you check is there any node that is prerequisite of 1, any node that is 0 comma prerequisite of the pop element. So it is E. So this for loop is continue. After I is equal to 0, G 0 1. Yeah, it is true. So for what are the neighbors of the present pop element 2? So we have to make sure a relationship between these 0. So in 2, we also make this as 2. I think this makes sense. What I am telling is, when you pop an element, you have to first find out what are the prerequisites of our popped element. So if is there any vertex that is prerequisite of our present popped element, it definitely prerequisite of this, the vertices that are neighbor to the popped element. So here the 2 is the neighbor of 1. So before processing 2, I am checking that is there any nodes that are prerequisite of 1. So for that I will traverse through this column. So I will get the 0 is the prerequisite of 1. So I will make sure that 0 is also prerequisite of 2. So I will make it as true. So in the question they give 0 and 1. So simply check what is this. This 0 is prerequisite of 1 or not. So here in the table we maintain the same. Is there any prerequisite between 0 and 1? We make it as true. So simply by checking the 0th row and the ith column, if it is true, definitely the 0 is prerequisite of 1. So let's see, in the 0th row, 1th column, it is true. So we return true. If they given query like this, 2 and 1, 2 and 1, when you see the row 2 and column 1, it is false, means no need to become the prerequisite of 1. So here we return false. This is the algorithm we use it to solve this problem. I will mention the code in I'm telling. See, if you want code, please check in the descriptions. I will provide the code. Is there any case? Please comment that. If you want to give any suggestions to me, please give me. I will improve what I will consider what your suggestions. Thank you.